welcome everybody. And today in this video, I'm going to be going over how to set a service policy and police traffic based on bandwidth percentage, bits per second, things like that. And I'm also going to be going over how to set up a bridge domain for a CSR. This is very similar to a BDI or bridge virtual interface when it comes to Cisco iOS, but since I'm using the CSR 1000V, which is an XE platform, it is now called BDI, and the configuration is different than the iOS version. Here's the lay of the land. We have a virtual PC, just the GNS3 virtual PC, and then I also have a Kali Linux box with this IP address. So let's get into this virtual PC. And I was already doing some testing, but if I do show IP, that's its IP address. If I were to try to ping it right now, it does not work because it is on a separate broadcast domain based on this router. So let's go ahead and do some bridging configuration. Let's bring up CSR 1000V. And this is actually pretty simple. If you just go into the interface, and the commands that we need to do that aren't already there are like make sure negotiation auto is on, CDP enable, and then this service instance configuration. So if I do show run interface G1 real quick, that's the default, so no IP address. So I'll just do CDP enable, and we'll go straight into the service instance 100 and make sure we are using this protocol. And then we go in encapsulation untagged and then use the bridge domain ID. Do this into the same thing for interface G2. Just hit the up arrow. And then that should be it. Let me do that. And let's go back to the PC. And now we could ping. All right, good. So we have connectivity between the Kali Linux box and PC1. So let me break this down and let me do some wire captures on this line. And let's say this Kali Linux box, they want to do let's say a SYN flood attack. And us being the network engineers, we can't 100% stop that. I mean, yes, we can. We could deny all traffic, but then if you deny everything, then your services won't be running, or at least your customers won't be getting what they need. So we can actually slow it down and then do further investigation later. But if you know that a SYN flood attack is happening, you can actually slow it down based on those specific packets. Let's look at Kali. And we're going to be using HPing3. Did Wireshark come up? Start Wireshark. And let me verify that it is capturing the traffic. Okay, it is. I hate all these things. Let's apply filter, not selected. Let's get rid of ARP. Not selected. Let's do some pings. Verify that this is working. Good, it is working. Filter out ICMP. And let's do a SYN flood attack on Kali Linux. I already did this before, but what we're going to do is we're going to do this sudo hping3 -c15000 -d120, and I'll go over all of this. And actually, I got this command off of firewall cx, but basically that command that I'm doing, where is it? Right here. So this command, so the -c is we're sending 15,000 packets. The -d is size of 120 bytes. We are going to specify the SYN flag, so this is why it's a SYN flood with a -s. And then the window size is going to be for 64. The port is going to be 80. The flood command is going to say send packets as fast as possible, and then we're going to do a random source IP address. And then what is our our PC that we're attacking? You just put in the IP address at the end. So that's what I have here. And the IP address, of course, is that virtual PC. So I'm just going to hit enter, put in my password. And now we can see here that it's getting flooded with SYN packets. In just a couple of seconds, it's reached 5,000, 6,000 within the seconds that we started this. So that PC is probably going to be flooded with all these SYN attacks, these SYN packets, and it's trying to open its session. So it actually should have had some SYN acts. So it's trying to say, okay, you want to SYN with me? I acknowledge. You want to SYN back, and this is where he's supposed to do the complete the three-way handshake, but it never is completed. So he's wasting all of his resources trying to say there's these open sessions. So that's bad. Also, let me filter this out because I don't want to see them anymore. All I want to see are the attacks or the SYNs. So within those seconds, yeah, it sent 7,000 packets, and we could have just kept that going. So what we're going to do is we are going to set a access list to identify those SYN packets using this commands right here. We're going to put it in a class map, put it in a policy, and then put in the police rate. This is where we could actually choose how we want to do it, and I can show you how to completely stop that based on these SYN attacks, those SYN packets, and then I'll also change the policing that we can do so I could show you the different types of options that we can do. So let's go into the router. And the first thing we need to do is we need to identify that SYN packet. So we're just going to do access list 105, which is going to be an extended list. And then we can actually do this all in one command, actually. So we're going to say we're going to permit TCP traffic coming from any source, going to any destination, although I could say specifically this IP address, but it doesn't really matter. But after that, we want to target, and this is where you could see the options for your access list. Do you want to identify, port ranges, the FIN bit in that TCP handshake, or the TCP finish handshake? But we want to focus on SYN. So this is the initial one, so we're just going to do that. And then we're going to apply this access list into a class map, and then apply that into a policy map. And then we apply that to the interface. So we'll just say class map, question mark, and we'll just put in the word. And that would be test. And then we are going to match on the access group 105, which we identified up here. And then that is it. We'll exit and we'll say policy map. And then what is this going to be? This is going to be SYN test. We'll say policy. And we will apply the class map of SYN underscore test. And then notice that we are now in a class underneath it. And then we are going to police it. So we'll say police. And then what do we want to do here? We can do, let's say, we'll just say rate, and I'll do this up here. We'll do a % of 1 of the bandwidth. And then we're going to say conform action. And we can actually do a couple things. We can transmit it, we could drop it, we could set some other, we could rewrite the quality of service bits. But just to show you that this is going to 100% kill everything, we're going to say confirm action drop, exceed action drop. And then we are going to apply this to the interface right here with a service policy input. All right, so we're going to go into G1 and we'll say service policy input, and then what is the name? And that name was SYN policy, SYN test policy. And then that's it, right? Yep. So now it's saying if these SYN packets, if it reaches 100% or even less, or I'm sorry, if it reaches 1% or even less than 1%, we are going to actually drop it. And if it goes above 1% of the bandwidth, then it is also going to be dropped. So I'm showing you that this is going to completely kill this. So I applied it. Let's go ahead and apply this attack again. It's attacking. And notice that these the Wireshark capture, no packets are being moved. And if we do a end show policy map interface G1, we can see how many packets are conformed and they're being dropped, how many packets are being exceeded, and they're still being dropped. All right, and nothing's happening. We stopped all SYN messages to this PC. Is that good? Probably not, because nothing can communicate with it via TCP. So let's stop that attack. And then let's change that police rate to something else. Let's see, it was that. We'll go into class map, and then we'll bring up this right here. So instead of saying police rate 1%, we could actually just say transmit. And that would work. And show run include policy map. Section. Okay, so now we are only allowing, so if it's under 1%, we're going to transmit, and then anything above that, we're going to drop. So we should see some packets go through. Right now we're at 7742. Let's start that attack again. And it's allowing it. It's still going pretty fast, but it's only using 1% of its bandwidth. And if we do a show policy map, we get to see how many packets are being transmitted, how many are actually being exceeded, and then they're still being dropped. But the attack is still happening, but we're slowing it down. We are dropping some packets, but we could actually slow it down even more by changing this police rate. And I'll show you how to do that. So let's stop that. Go back into the policy map, go into that class. And this is where we're going to change. Instead of it being percent, so we're going to say police, and we will do 8,000. So this is only 8,000 bits per second. And then we are going to say conform action, we will transmit, and then exceed action, we will drop. So this means we're only allowing 8,000 bits per second. And if you remember how big our packet size is, this is 120 bytes. So, and we're only allowing 8 bytes at a time. Or I'm sorry, yeah, 8 bytes, because it's 8,000 bits. So once I apply this, hit enter, and we are at 32,268, and we start this attack again, you'll see our SYN messages only go up by a few every single time. So we're still on 32,400, and our attack is now being slowed down tremendously just because I set this police to 8,000 bits per second. So go back into the policy map, we get to see our configuration here. All these packets are being conformed, and they're being transmitted, and they're being dropped. I think this is ever since I set this policy together. But you can see that this has been slowed down tremendously. And that's how you can police your bandwidth or the input of packets as they're coming in. You have to identify what the packets are. So in this case, I did the SYN messages with this access list. I identified them there, and then I applied it to a class map, and then applied that to a policy, and that policy has a police of 8,000, and then I simply applied it to the interface in the input fashion. You could also do this on output or input, it doesn't really matter. So that's it. I just wanted to show you how to do a couple things in this video, and how to potentially slow down or stop an attack if you know that it's happening. So that was it. I hope this was very informative for you, and thank you for listening.